The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Many episodes ago, we did a 16-bit console war episode where we compared the Sega Genesis to the Super Nintendo.
Now we're going to do the same with the Nintendo 64 and the PlayStation 1.
That's right, 32-bit console wars. We're going to take them apart, look at the insides, compare their architectures, talk about the pros and cons, and then look at some of the games that made the consoles so popular. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Well, we can't do a comparison video of game consoles without taking them apart, can we? So let's do a teardown on the classic PlayStation 1. This isn't the original PlayStation 1 because it doesn't have the parallel output on it. I mean, it's a pretty old one, but there was actually one more connector on the original PlayStation 1 from 1995 that they removed because people were using it to cheat. So this one I think I bought in 98 or 97. It was a few years in. So of course the famous backstory behind the PlayStation 1 is that originally it was going to be an add-on for the Super Nintendo. And, you know, as we've seen recently on the internet, someone actually found a working prototype of it. You know, it's one of those things like, I'd never thought they'd find one. I didn't even think it existed, but apparently it did, which just proves anything could be out there, even Jimmy Hoffa's corpse. But what happened was Nintendo didn't really want to work with Sony, and they're like, oh, we'll do something with Philips instead. And the Sony's like, okay, well, we'll just make our own console. And yeah, that didn't work out super great for Nintendo, did it? Which is kind of ironic because the original Nintendo Entertainment System was going to be released in America by Atari. Yes, Atari CEO saw Donkey Kong, a Nintendo game, running on the ColecoVision, and he got mad and then he canceled the deal. Well, here's the inside of the PlayStation 1. We have the CD-ROM drive, which is just held in place by prayer, I guess. Well, no, it sticks onto these brass tabs, and then on the inside here, see there's holders on top. So basically that gave it kind of a rubber suspension, so to speak. So a big advantage that the PlayStation 1 had over the N64 were the CD-ROM discs. And it wasn't just the capacity of the discs, although that was a big deal. A cartridge, like on the N64, requires a plastic shell. It has a PCB in it, and there's mask ROM. So it's actually very expensive to manufacture versus a single compact disc, which was almost basically free. I mean, it was so cheap to manufacture that. And that's one of the big reasons that the PlayStation 1 did so well back in the 90s. Nowadays, the nostalgic system is the N64, but back in the 90s, the PS1 basically ate its lunch. Well, clearly at one time, this board was bigger. See this gap here? They obviously costed it down. Hey, I found the data sheet for one of these chips. This is a 512K RAM chip, and it's connected directly to this. So according to the Wikipedia, which never lies, there's 512K of audio RAM. So this is the audio RAM, and this is the audio processor. So PlayStation 1 has its own separate audio chip, whereas the N64 has that built into the CPU. So I know what this RAM chip is. I'm guessing that this and this are also RAM chips. One of them is going to be 1 meg and the other one's going to be 2 megs. And then by identifying which one is which, I can then identify what chips are connected to it and then figure out which one is the GPU or the CPU, because Taylor Swift. So the RAM is going to be connected to the CPU and the VRAM is going to be connected to the video chip. I mean, it's kind of obvious. So these two go together and these go together. So I guess I could probably try to identify the chip and then I'll know which RAM is which in theory, unless I don't. Of course, the two large chips here aren't labeled anything. On the later PlayStation units, they get a little bit more pretentious. They're labeled like the reality synthesizer and the emotion engine. All right, in the data sheet, it says that IC106 is DRAM, 16 megabit. So if you divide that by 8, you get 2 megabytes. So this is the main RAM of the system. So I'll just call it W for work RAM. And it is in close proximity to this, so I'm going to guess that this is the CPU. Okay, so this is a 32-bit RISC CPU, which is reduced instruction set computer. It also contains a geometry transformation engine, a motion decoder for playing video, and a system control coprocessor, which is probably like a bus arbiter or something like that. And then this is the RAM for it. The CPU talks to which this has to be the GPU. So it's basically just a 32-bit graphics processor. And from a talk with a friend of mine, the GPU was pretty dumb. The CPU had to tell it everything to do. So the CPU would actually create the graphics engine, then it would send all of the texture data over to the GPU that would render it. So you're always having to constantly update it. The GPU could render things, but that was about it. It was up to the CPU to tell it what to do. Okay, so the CPU talks to its RAM, which is the work RAM. Also talks to the GPU, which uses the VRAM, and the audio chip that has the audio RAM. So each chip has its own RAM, which means there's probably a lot of contention on the bus. So that's probably something you have to think about. This is probably some sort of video encoder, IC102. Let's see if I'm right. So now I'm just kind of guessing and seeing if I'm right by looking at the data sheet. Oh, nope. That is a boot ROM. 512K, all right. That I would not have guessed. And this here is obviously the motor controller. Where is the video output? I think it's this one. All right, let's take a look at the board itself. I wonder if this was a multi-layer board. So none of the chips are BGA, all the pins are visible. So this is probably a 2-layer board, or at most it might be a 4-layer board with internal power planes. But it looks like all the traces are, visible on the surface. It's not actually that big. I wonder if you could make this into like a portable or something. Okay, now we're gonna do a brief overview of the PlayStation 1. So PlayStation 1 has 3 main components: CPU, a GPU, and I guess we'll call it an APU. That's the audio processing unit. So of course you have your spinner disc here, and there's some additional circuitry that drives the CD-ROM, and that is all loaded by the CPU into the CPU's work RAM. And that's 2 megs. 2 mega B, uppercase B means bytes, lowercase b means bits. Fun fact. So in this system, you have separate RAM for everything, which means the RAM isn't in contention. However, you have to be more careful about your bus because you've got 3 main things on the bus that are all vying for attention. So the APU has RAM as well. That's 512 KB, half a meg. And GPU has some RAM, which I guess you call VRAM, video. That's 1 megabyte. So the thing that will take more time, and if you remember the PlayStation 1 days, there were a lot of loading screens. So CPU has to load data off of the disk into its RAM and then send it to the GPU. So this is where all the textures and the color tables and the, basically the video stuff would be stored down here in this RAM. And if you had fewer textures, you could fit more things in it. So anytime you get away with like flat shading, if you look at a game like Mario 64, granted that was on the N64, Mario himself only had a few textures. Most of him was just colors. So that would actually save you a lot of space. So you could load up these 3 things separately: the video RAM, the work RAM, and the audio RAM. However, it took longer to do that, and that's why you had all the loading screens. So in this system, everything is separated out, which is good, but the problem you're gonna have is bus contention, talking to the right thing at the right time with your CPU. And your CPU, along with being a lot slower than the N64 CPU, is also having to do pretty much the whole graphic engine, telling the GPU, which is basically just a chip that you tell it what you're like, okay, draw this, and that's all you can really tell it to do is just draw things. It's not really that much of a coprocessor. So the PlayStation 1, the CPU is having to do quite a bit. And the APU, just does your audio. Well, I guess actually the APU also controls the CD-ROM. So I guess that part was a little inaccurate in my early drawing. But yeah, it's more of a parallel system. So they're done differently. They both were challenges back in the 90s to program in different ways. But in general, the developers preferred the PlayStation 1 because it was a little bit more straightforward and it had a lot better documentation for third parties. I mean, Nintendo really hasn't been super great for third parties ever since the Super Nintendo days, and there are reasons for that. It comes down to support. Here are the pros of the PlayStation 1. The CD-ROM media was very cheap for third parties to manufacture, meaning more profit per game as compared to a cartridge system. Plus, the CD-ROMs had much more storage than cartridges, which means you didn't have to compress it as much and you could have just bigger games in general. The development kits for the N64 had better support and were cheaper than the N64 equivalents. And there was faster access to parallel RAM for the individual integrated circuits. PlayStation 1 cons. Flaws in the hardware caused polygons to warp when too close to the camera. Disk loading was slow and data had to be carefully arranged on the disk depending on how often you needed it. Less RAM than the N64, and the RAM on the PlayStation also had to store the game code versus the Nintendo 64 where it could stream the code off of the cartridge. Multiple components complicated the bus management, and the VRAM controlled by the GPU slowed down the access time to it. Now it's time for a research update. I've been doing some research about an upcoming episode regarding mechanical television. It was something they had back in the 20s where they would use a spinning disc to record an image, transmit it, and then the people at home would have another spinning disc and a very small screen, and they could see reproductions of images. It's actually kind of obscure now, but it was actually, broadcast in both America and parts of Europe. So we're gonna try to rebuild that. I need to find all the parts I need. I've got some stuff from Ultimate 14, of course, photocells and large LEDs to both do the sensing and the reproduction of it. But I'm looking for spinning discs. Now, obviously we could cut something in the laser, but I wanna try to find something that already exists. They said that those discs were about 30 centimeters, so I think a record, like an old LP, might actually be the best bet. So I'm gonna make a trip to the thrift store today, try to find a bunch of LPs that nobody cares about, and then cut laser holes into them. And also they've got a hole in the center, they're lightweight. I think it's a pretty good bet. So yeah, hopefully I can find all the parts I need in time for the episode. Let's take a look inside of the Nintendo 64. Oh yeah. Well, there's a power brick on the back of it. No mystery as to the power on this, 3.3 volts and 12 volts. Well, that was a lot easier to figure out than the PlayStation 1. Here is the expansion port. Oh no, I voided the warranty sticker. Well, that's dumb. Look at this. They put the warranty sticker over this, but the thing is, if you just fold it open, it wouldn't ruin the sticker, but now I guess the warranty is void. Well, we're gonna void it even more by opening it up. Actually, in Japan, they had a Nintendo DD disk drive that would go on the bottom of this, and there were some disc-based games, but I don't think anyone really bought it. So the screws on the Nintendo 64 are once again weird. So we're gonna do this trick where we take an acrylic pen and we heat it up and then we use it to make a bit. Once the pen cools over the head of the screw, you can then remove it. Ta-da! See, basically made our own bit. And the reason why you want to use an acrylic pen for this, not a plastic pen, is because the plastic won't have enough rigidity to work. This should be the last screw, actually. Do not remove jumper pack. Well, that means remove the jumper pack. So this is where the extra memory went. But there are pins just in this jumper pack, so it's probably some sort of bus terminator. Without this, it doesn't know where the end of the RAM bus is. Time to open her up. Well, here's something that systems have in common. The top piece of the case is completely separate. So the Super Nintendo ran at a pretty high frequency compared to the PlayStation 1. It didn't have any fans, but it does have this big, feels like aluminum heat spreader, and it's going around at least two of the main chips. So let's dive further into this. Oh, it's the inside of the Nintendo 64. Everything I dreamed it would be, and more. So yes, the Nintendo 64 was a 64-bit system. However, most of it operates at 32 bits, and even then there aren't a whole lot of 64-bit operations because those would take up more space on the precious cartridge, and if you didn't need to use them, it was better to save memory than to have the 64-bit power. Okay, so there are heat sinks on this versus the PlayStation because the main CPU on this runs at about, I want to say it's 98 megahertz. I could double check that though. Yes, okay, 93.75 megahertz, which is almost 3 times faster than the PlayStation 1. Oh, looks like this one's gonna come off first. All right. Oh, there's a chip. That is most definitely going to be the RAM. See how the RAM connects to the video processor and then it goes to the expansion port? So the expansion port simply added more RAM to your N64 system. Now it's using something called RAM bus, which was pretty new at the time. So you might notice this RAM has a lot fewer pins than the RAM on the PlayStation 1. Now the PlayStation 1 is a 32-bit console, but the RAM was accessed with a 16-bit data bus. Here, it's a 64-bit data bus and the RAM's being accessed with 9 bits. So you'd actually have to do multiple cycles to get all of the memory out of the RAM. However, it was at a much higher speed, which made up for it. And below the RAM, we see the expansion port, and that is what would expand your RAM from 4 megabytes to 8. So even in the base configuration, the Nintendo 64 had more RAM than the PlayStation 1, which would have been 2 plus 1 plus 5, 12, 3.5 megabytes versus 4. Yeah, still pretty close, but with this puppy, you doubled it. Oh yeah. So I'm thinking that there must be some sort of termination that has to happen, even though this is just the null cartridge that comes with it. Without this in place, the system won't boot. So it must, terminate the end of the RAM bus. Oh, RAM bus. And without that termination, it doesn't know that it's the end of the chain and therefore it doesn't work. Let's look at the next chip before we get into the RAM bus. So this is going to be your video processor. Something of note, and this is really important to note, is there's a unified memory architecture on this, which means the logic RAM and the video RAM are on the same RAM, which is similar to our newer video game consoles such as the Xbox 360, PlayStation 4, and the Xbox One. And also if you have a computer that has a combination GPU, CPU, and you don't have a video card, it too would be using your RAM as both video and random access memory. The problem with that in a system such as this is the CPU has to go through the video chip to get to the RAM. And in those situations, it would only be allowed access to the RAM when the video chip isn't using it, which means it creates a bottleneck, and that's where some of the problems come in. So even though you have 3 times the speed of the PlayStation, since you don't have a discrete RAM for your work and video operations, it's going to slow you down. Let's pop open the CPU here. All right. Those look almost identical. So yeah, this is the CPU, and it looks like the CPU mostly is connected to the video processor. The cartridge seems to also go entirely to the video. Yeah, that kind of sucks. Let's take a look at this. I found someone drew a schematic online. I'm gonna take a look. Yeah, the majority of the cartridge connections go to the video chip. So the video chip probably also acts as some sort of bus arbiter where it basically allows the whole system to run. And that's probably why you have bottlenecks. So even though the Nintendo 64 is faster, with this simplified architecture, it creates other problems for itself. Okay, I'm actually gonna clean up these chips and then we will start marking them. I've identified most of the chips by cross-referencing them to the schematic. So this is the video encoder. It takes data from the GPU and turns it into analog RGB signals. This is the audio amplifier. We can see right here that there are a pair of capacitors and thick traces, and this goes right up to the AV port. This chip drives the controllers. The Nintendo 64 has basically one wire communication with the controller, so it has a special chip that does that. And that's pretty much it. There's a few other extra chips and regulators, but those are the main parts of the system. CPU, GPU, RAM, video encoder, controllers, and audio booster. So yeah, pretty simple. There is also this expansion port on the bottom, and if you look at it, it's exactly where the cartridge is. And you can actually pull the cartridge slot off, see that? And that's how that goes together. And there's all sorts of wonderful dust and who knows what else trapped in there from kids. I'm going to draw up a brief overview of the N64. So the heart of it is going to be the GPU. Oh yeah. GPU connects to the cartridge slot, as we saw, and the CPU connects to the GPU. So the GPU is really kind of driving the show. And if you remember our ZX Spectrum projects, we learned from that in that system as well, the GPU controlled the show because you always want to have the screen drawing. So the limitation with the N64 is that the RAM, there's one bank of RAM, which is kind of nice in a way, but it's controlled by the GPU. So if the CPU wants the RAM, it has to say, hey GPU, yeah, are you doing anything with the RAM right now? Yeah, I am. Oh, okay, I'll wait. Hey, you doing anything with the RAM? No, okay, now I can use it. But otherwise, the GPU is probably going to have priority to the RAM in order to draw the screen, which it sends out to the other circuits, which plug into, your television. And then also those additional circuits get the information from the controllers as well. Those weird banana-shaped things on the N64. Yeah, so it's a simplified architecture, but with that simplicity comes some limitations, mostly in RAM access. Nintendo 64 pros. There's a faster CPU and GPU compared to the PlayStation 1, almost 3 times as fast. Fast access to the cartridge, no loading off the CD-ROM. The program runs directly off the cartridge, saving RAM space. There was more RAM than the PS1 in general, especially with the expansion pack, which could bump you up to 8 megabytes. And the polygon rendering was much better than the PS1. Nintendo 64 negatives include cartridges that were very expensive to manufacture compared to CD-ROMs, meaning less profit for the developers. Cartridges were also very limited in size. 16 megs was pretty normal. 64 megabyte was the absolute maximum, so not a lot of room to work with. There's also a really small texture buffer, which meant you had a lot of blurry textures with a lot of repeats. Development kits were more expensive and harder to use compared to the PlayStation 1, and it required more low-level work, machine language assembly, to get full usage out of the hardware. You couldn't do as much of the game in C as you could with the competition. So to recap, this was the first generation to use mostly high-level languages like C. There was still some assembly programming required to get the most out of each system. The N64 required this more than the PS1, which made it a little harder for developers to use. The N64 has a simpler architecture, but it is harder to program because the GPU and the CPU both share the same RAM. Even though their clock speed is about 3 times that of the PlayStation 1, they're slowed down by memory contention issues. The PlayStation 1 has more parts, but it's easier to program. Each major component of the system has its own dedicated RAM. And the big kicker, which is really why PlayStation won the war, CD-ROMs were cheaper than cartridges, which meant the devs could make more money per game, which meant more devs made games for the PlayStation 1. There were more games available, and therefore more PlayStation 1 consoles sold. Even though the consoles, N64 and PlayStation 1, were pretty similar in price, the PlayStation outsold the N64 3-1 based off the strength of its library. Okay, we've talked about the hardware, which is all well and good, but now let's look at the games for each system.
So the N64 had a lot of really great titles. One of the nice things about the N64 is there was 4 players as opposed to the traditional 2, so there were a lot of really great games you could get together with your friends and play them. So there was GoldenEye, which was your FPS.
Oh yeah!
Those guys, that was good. Star Fox was either you could play it as one player or you could do battle mode and fight your friends.
You could also do barrel rolls.
Barrel roll, yeah.
Do a barrel roll!
Super Smash Brothers was hugely popular because you could just continue, endlessly battle your friends.
Would it have been nearly as much fun with just 2 controllers?
Nope. Had to have 4. And then Mario Kart 64, which again was nice because you could race your friends, or you could do battle mode where you'd have 3 balloons off the back of your cart and you had to pop your friends' balloons, and if you were the first to die and there were still other more than one player left, you could be the bomb and try to get revenge for them killing you.
Sounds fun.
That's good. And then it had some really good just single player adventure games. So you had #1 favorite, Ocarina of Time.
As you couldn't tell from the t-shirt.
Yeah. So I really liked it because I didn't always want to just, barrel through the game and just get it beat and always beat the big bad guy. A lot of times I'd be I don't feel like going and spending 4 hours in a dungeon. I want to go do some random side quest, and this game was chock full of side quests. But it also had a really good storyline, so it was good.
So it's kind of like a modern Bethesda title where you don't even have to progress the story.
Yeah, I mean, it wasn't as open, but yeah. So then you've got your good games for the youngins, like Yoshi's Story, where it's kind of hard to die. And then M for mature, Conker's Bad Fur Day, where you play a drunken squirrel. It's awesome.
You know, Conker started out as a cute fuzzy squirrel in like a kid's game,
Yeah.
but then Rare's like, let's turn him into that.
So yeah, there were a lot of really great titles for the 64. What about the PlayStation?
Well, we grabbed as many as we could find.
Not that many.
So there are tons of licensed titles because I guess licenses were actually really cheap to do back then. In some cases, the licensor would actually pay you to make the game, basically just to promote their product.
That's backwards.
So here's a big thing that people liked on the PlayStation. There are a lot of RPGs that could use the larger disc size to have not just cutscenes, but just more scenes in general. And there were some games that came on multiple discs. So if you're talking like 16 megs right there versus 1.5 gigabytes, I mean, that's a pretty big difference in the amount of depth you can give people. So Nintendo, or Super Nintendo was really big for RPGs, but then the RPG market kind of went entirely to the PlayStation 1, and that's a big reason why they were so popular. Here's one of their early mascots, Crash Bandicoot.
Yeah, that was a good game.
Look at this, Naughty Dog, who would later make Uncharted, Drake's Fortune, and Uncharted 2 and 3, and now 4. So I want to briefly talk about this. This is Medal of Honor. This was an early game from DreamWorks, and this was kind of late in the PlayStation 1's life. This is kind of PlayStation's answer to GoldenEye. So it was novel because it was the first game back then to take place in World War II. It was produced by Steven Spielberg from a concept of his, made it DreamWorks Interactive. So then this game had a sequel, Medal of Honor Allied Assault on PC, which was fantastic, which was made by 2015. And that company changed its name to Infinity Ward, went to Activision, made Call of Duty, and the rest is history. And something else about this game, it's got a score by Michael Giacchino, who's a fantastic composer. He started out in video games, and then he got into movies, and most recently he did the score for pretty much every J.J. Abrams film except for Force Awakens, and also Pixar. He did like Inside Out and Up.
Oh.
Great composer.
Yeah.
So what were your favorite Nintendo 64 and PlayStation 1 games? Which console did you think was the best?
Let us know on the Element 14 community on element14.com/TBHS.
Where you can also read about our other upcoming episodes, builds, and special events. We'll see you next time. Let's play some games. Yeah, Medal of Honor. Yeah.
So you think you can come into my jungle and bring your man ways with you? It's me, Mario. I'm in the mob.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.